So if we do this, I think we can have first-rate human problem solvers, not third-rate human computers, which is what we're currently educating people for. You need to work up a level in an industrial revolution, not pretend you're going to mimic the machine and basically lose your job. And we also need to make sure people are aware how to work with the computer for optimized decision-taking. I want to talk about what I believe is the underlying technology of our age, taming computation, and how we can gain more what I would call computational intelligence for all humans. So computation is a very powerful idea that we've sort of started to take for granted. The idea that you can work things out and get an answer that's very precise in some cases is something that has been growing over the last decades. And the question is, how much further can it take us? Where are we on this trajectory? And if you want a historical perspective, I think the most equivalent sort of piece of history is electricity, the rise of electricity. But probably computation is about 150 years behind that. And as you know, with electricity, we are still finding new applications, new ways to tame it, even though Faraday ran the first motor in the Royal Institution, I think, in 1821. So we are on this sort of trajectory, that level of trajectory of driving change in society. And of course, this is the big underlying change that has allowed the application of AI. Why is it so powerful? Because it's a mechanized way, now mechanized by machines, to get what I would call high-fidelity answers. We can discuss things in English, and we get some kind of answer. You can often, not always, get a much higher fidelity answer by working out the result. And now, because of the machinery we have, it is available across almost all walks of life. The other reason of why now is because we have machinery available almost all the time. If you're in a developed country, like I suppose the UK is, then you do most of the time have computational tools with you. You've got your phone, you've got your computer, you've got the cloud. They're everywhere. And so we've got this power as an extra piece to our intelligence all the time. The big question is how accessible it is as available. So what are we doing at Wolfram? Well, for coming up to 37 years, actually, if I can count, we have been trying to build the ultimate ecosystem for delivering computation at every level. We believe in the power of computation, and we've been trying to build out the ultimate infrastructure for delivering that. And it started with Mathematica in 1988, named by Steve Jobs, by the way, and ended up, most recently with a hybrid AI that I'll talk more about, and many pieces of consulting that we do around the technology. It's not just delivering technology, it's also allowing people to understand this better. So, let me start with basics. What is this extremely powerful process I talk of? A rough summary is its 4 steps. You define a problem. How long could I speak before everybody in this room runs out of air, for example? Can I overdo it? How do you abstract that to an abstract form that gives tremendous power beyond the context in itself? So that's what traditionally we do in mathematical expression, now is usually code. How do you move that question in abstract form to an answer? And finally, how do you interpret that back to answer the question you started with? X equals 3. Did that mean 3 hours? Does that make sense? So that's the process of maths and computation that's been running over hundreds of years, but is now supercharged beyond any imagination. So let's go back to the end of 2022, before AI hit. There were areas, subjects, if you like, fields that were always to do with computation. Maths itself, physics and accounting have been very long-standing beneficiaries of computation. Then there are areas that are newly conceived. Programming, data science, social media, these are all, and AI existed, of course, these are all, so to speak, newly conceived because of this power. And this third column is very interesting. These are subjects that have been around forever, well, not ever, but a long time, but now fundamentally have a new to computation element. You can now do much better in biosciences or medicine or marketing and business by deploying computation, but they're not new because of it. So, a very simple example here. If I want to try and analyze let's say I want to look for a sequence in the human genome. This was unthinkable not that long ago. Now, I can just ask for it. There it is, straight on my laptop. 20 years ago, I think it was in the Clinton era, they were starting to think, could you sequence this in a lifetime? Now I can get it in a second. This is computational biology at work, so to speak. Here's a Lord of the Flies analysis. How do the sentiments change through it? And with a very, very sort of short piece of code, you can literally pull the data in. This is the total code to generate this, analyze the whole book, and figure out what's going on. So that is a typical computational computational English or something, whatever you want to call that. So that was all doable and there very much end of 2022. Let's move to 2023. We now have this major ability to, in a sense, combine the accessibility that you would have from just speaking to your computer with potentially this power back there. So it's a kind of combination of, in a sense, the computational world and the human world. It's a new dimension of automation between those. So it's itself, of course, an achievement of thousands of years, basically, of computational ideas, but particularly the last 50 years of computers. So a typical thing we can now do, make me a program to show EU countries each marked with their GDP per person. So if I do this, this is our new notebook assistant has come back, and it's actually written the program for me. It's also actually explained what it was doing. And now if I evaluate that, there we get a map that really is there. It's functioning. There's the program. I might have had to write that by hand, but now here it is. It's even realized that we've Brexited. So I think if I change the color function to something, we can probably change this. Let's see if rainbow is an option. And then we can hopefully redo the coloring there like that. So my point is, there's an interesting interplay between English speaking to it and taking abstract code and actually working with it. I do not believe that we are replacing abstraction explicitly for humans, but I do believe it's very useful to be able to change this. So let me step back for a moment and says, has more data and complex models in the world over the last few decades led to better decisions? Well, it hasn't been a great line, and of course we like to make a model for everything, so you can decide which line it is, but I think it's less that and more that. So I wanted to talk a bit about what's wrong and how can we fix it. Where has the computational story here gone wrong, and where do we go next? So there are a lot of barriers to good answers, and I've listed some of them here. Trust, whether quantitative is actually better than qualitative in some cases, but the summary is we've done a lot of using numbers beyond their ability to answer or to judge. And we see this across society. A simplistic number is often picked beyond its ability actually to represent the situation because it's got a great marketing panache. The other problem is, you've got to get the right tech, right? So we've got LLMs, they're wonderful, they're fantastic new innovation, but they aren't the same as deliberately computing things. So if you take our Wolfram Alpha, which I would call a symbolic AI, it actually is very complementary to modern generative AI because it can do logical things that LLMs are really quite bad at, but it isn't very good at talking to people. We're at the Aspergic end of the spectrum very much. Another thing that we need to fix is the right interface. So we've got many more opportunities for interfacing things. This was a report, actually, many years ago, in fact, for the House Committee on Insurance for Texas. Should it buy hurricane insurance? And this was actually presented as a typical thing. Let's not just discuss, let's actually play with the model in the hearing and see whether we can argue about where things should be. There's much more ability to do different interfaces and actually play with real data in real time. I don't think this was being done in government during the pandemic. I think there were flat PDFs most of the time. That was an error. So one of the questions that's come up very recently with LLMs is, what's the right level of abstraction for the human? Do we still need to write sort of explicit code? And I suppose I summarize this in a recent blog post by saying, now computers talk human, do humans need to talk computer? So my argument is, yes, we do need to have appreciation of explicit code, but more as editors more of the time than as initial generators. So there is an important interplay. You do have to understand abstraction going forwards because it's got a precision that we don't have with just speaking English. So there's a power to that, but we can do far better at generating it and using it. So in a sense, I think we are coming into a new era of citizen programming using the power of abstraction, but not with citizens needing necessarily to write code in the way that we thought a few years ago. So Wolfram Language we've been building, as I said, for many years, and there are I've put 3 wolves up here. This is our emblem for it, the wolf and the ram, if you like. This is the wolf element. Anyway, we think of ourselves as a programming language, but also a superset to represent all computation. So we've been trying to write the language where you can easily find the word that says, oh yes, this was the computational idea I wanted, and now we've actually got something to run it on a computer. And also a way to communicate this. It's a funny thing in Wolfram in meetings sometimes that people say, rather than just explaining what I'm going to do, I'm just going to write you the little Wolfram language thing to explain what I meant. Here it is. Oh yes, I understand what that means now. So you can actually sort of understand things that way. I want to zoom out a moment to sort of the critical issue here of how can we do better at this decision making in this computational era? And go back to this thing about quantification beyond its ability to judge. Because I believe this is a pernicious problem. I'm a great supporter of computation, of course. I've worked on it for many, many years. But I don't think we are necessarily societally set up well to do well with it at the moment. And this simplistic quantification I mentioned has many effects that we see. So the idea is, you're said, well, if you run a hospital, you need to produce 3 metrics that explain whether your hospital's running well or not. Well, unless you're pretty incompetent, you'll make sure the 3 metrics are hit, but that doesn't well represent the complexity of the hospital. Before we had numbers like that, we just sort of guessed, well, it was running well or not running well. It was a very qualitative thing. So the key issue is how to put these together, but not get fooled by numbers that don't really have that power to represent the full situation. So it's kind of like, you get a poor outcome, you optimize for the poor outcome, you get very confused, and then the thing doesn't hit what you wanted, and things seem actually worse than when you started. And this ends up with a big loss of trust in the power of computation. And, lockdowns were a key thing here, people over-claiming for what they could model, as well as useful models, economic effects, et cetera, et cetera. So another part of this is claiming you can, in practice, compute something when you can't. There are things that just have too big error bars, they're too complex, there's not a lot you can say that's better than qualitatively thinking about it. And we've got to be honest about those cases and not deal with it, not pretend they're not there. So, several solutions. Richer computation. The more sophisticated your computation, if you deploy it properly, the more likely it is you can deal with messy situations and get real answers out. Don't use simplistic quantification on messy cases. It doesn't work very well. That's why the power of modern computing power has enabled us to go into these messier areas like medicine and actually produce useful results. Because we have that power, but we've got to use it properly, and that often isn't happening. Agile metrics, the idea that you can set up a computable data set to represent, let's say, the hospital example. Each person asking about that can ask about what they want to get the information out. Not, here are the metrics. The metrics go with the person asking, not generated by the person producing them. And the thing I just want to end a bit by talking about, which is computational literacy for all. We need decision makers given the power to drive, but that means we humans need to get better at understanding how to do computational thinking, as I would call it. So for the AI age we're entering, I believe we absolutely and urgently need core computational thinking and literacy embedded in our education. And I put these sort of on a spectrum. I think of computational literacy as everybody needs this all the time, just like you need literacy. Computational thinking is kind of, I think of as the higher end of this, the specialists. But between sort of survival up to value added, you all need this. So here's the crisis we've got. Find this in our, let's say, school curriculum, and you'll be lucky if you spot it. It isn't really there. The thing that's assumed to give this, and everybody's pushing, is maths. But the news from me is maths, in my view, is 80% off topic by the time you're at A-level. It's the wrong subject. And it's very simple to state why. In the real world, computers do almost all the calculating. In educational maths, people do almost all the calculating, and you have a total dichotomy there. However well you teach the wrong subject, it doesn't make it right. And this actually leads to a whole bunch of bad consequences. Wrong algorithms, wrong capabilities being emphasized, wrong style of thinking, poor handling of complexity, that's a really bad one because we don't handle it in education, and the management of automation, all the things coming up. So back to this picture that I showed you at the beginning, the 4 steps. In education, we're spending essentially all our time doing step 3 by hand. Very simplistic problems, and we're largely drowning out these other 3 steps that are so critical. So I started a company, computer-based math, some years ago to try and address this and basically build a computational curriculum that assumed computers exist. People sometimes find that quite funny. Well, obviously, but no government, no country in the world has a maths core curriculum that assumes computers exist. Not close. And the book I also wrote recently, which I'll be signing a bit later, is also to try and map out, in a sense, what we need to do from the problem to the solution to some of the politics around solving that. The sad thing is the UK could actually lead on this. We have the infrastructure to lead if we get our act together. Like, for example, having an alternative A-level that people could take, actually, to gain admission to top universities and things that would much better serve them for most purposes than the traditional maths we're doing. But we need to align everybody. The ecosystem for subject change in education around the world is really stuck. And we need to figure out how to get that unstuck quickly, because not only maths is affected, but all the other subjects as AI changes the real world. We've got to match the real world. So if we do this, I think we can have first-rate problems, human problem solvers, not third-rate human computers, which is what we're currently educating people for. You need to work up a level in an industrial revolution, not pretend you're going to mimic the machine and basically lose your job. And we also need to make sure people are aware how to work with the computer for optimized decision-taking. If we do education reform for the AI age, I think we can use maths as a template. We have to do that that's been going for decades as a problem, but there are going to be other ones coming out. And we really need this computational literacy for all. The idea of literacy for all seems obvious. It was born in the late 18th century, and most people thought it wasn't necessary. Most people didn't need to read and write. It just priests and aristocrats could tell you what to do, and that was fine. We're in a similar era now with computational literacy. We have a group who know it well, but that's not most of the population. So that's what we urgently need to fix. And I think LLMs and modern AI gives us a great opportunity to do that. Let's not do it on the wrong subject. So we can then achieve what I would call a computational knowledge economy, the future of the knowledge economy, but where we're basing it on a level up of being able to compute things and knowing how to operate that. And I think the biggest thing we might achieve is rebuilding trust, which we've lost through over-claiming for some of these computational ideas, but not knowing how to evaluate them as humans. Thanks very much indeed.
Thank you so much, Conrad. That was really fascinating, and covered some things I didn't think you were going to cover. You ended up about this idea about rebuilding trust, which of course is difficult to do, as we all know. And I thought to myself, and we live in a time as well where there seem to be, at least the perception is, there are an increasing amount of academic fraud as well. You know, that some well-publicized cases at Harvard and Stanford and other institutions around the world. And, I wonder if it was, as I sat there, and of course, sadly, our industry, of course, I think we termed vaporware as one of the famous terms of probably more pre-2000s, but I'm sure it still exists to some degree.
Oh yeah, particularly with AI.
Right, okay, well, that'll be my next question. But, is there a need for, it seems like basically, I guess part of the thing is that, if you have some knowledge, even a lot of knowledge about computation and what it can and cannot do, you also have power over most people, including other elites who look to you for what can we do. And of course, with power comes the temptation to abuse that power, which is not just true in computing. It's true for anybody
who has
with power of whatever form of it. And but I do wonder if there's almost a kind of need for computational and academic elites and others to, almost a sort of, like the Hippocratic Oath in medicine, is there a need for some sort of way of kind of almost reminding ourselves, like there are some ethical things we really need to think about?
I mean, you can do that, but I think in the end, what people need is experience of what computation does in a modern context, where it goes wrong, where you can't use it. And I think with that experience will come the necessary sort of skepticism, because you'll be able to ask the question. The average member of the public can ask much more about it. The fact that people can read and write now, particularly read, is really critical to questioning what we do. You wouldn't have modern politics, for all its pluses and minuses, but where people are controlling what happens without that ability in the population. So most decisions now are taken in life with a computational element. Do you wear a mask or get a vaccine? I think 50 years ago, that discussion would be far less computational than it was with this pandemic. But most people had no ability to understand really what was being said. Some of the people did a very good job, actually, at trying to get that across. Chris Whitty, for example, I think did an excellent job. Some of them overclaimed. They said, I can tell you that there are going to be 232,000 deaths if you do or don't do this. They didn't know, right? It was overclaiming for the modeling. But it gives people a lot of anxiety if they don't understand who to believe, because they've got no basis for that. And I think we do a fair good job in this country, for example, about history. People have some basis for evaluating what's happening now on a historical basis, because they have some education in that. We do a lousy job on this computation thing. And it's not about necessarily doing the calculations, even with a computer. Some of it's standing back and saying, is this cause or correlation? Does chocolate consumption, which is very well correlated with Nobel Prize in country, does eating more chocolate cause more Nobel Prizes? Well, there's probably another factor involved, right, is my instinct to that. So you need to have that kind of backbone, and we need to build that up over the years of education. And I think that's the best inoculation against some of this fraud and problem.
Okay. Moving on to AI, which obviously I've just mentioned, what do you move on to? There's obviously a very wide range of opinions about, particularly on AGI. Some argue that it's nearly here, if not actually here, and it's being hidden somehow, to it will never happen. Any thoughts on this topic? Well,
firstly, I think we've got to get the terms straight. Right. AI, in my book, is artificial intelligence, meaning what you're trying to achieve. There are different mechanisms for getting to that goal. There's the statistical AIs, I would call them, of LLMs, which have hit with a buzz in the last few years, which are fantastic, but they are one mechanism. And we have our symbolic AI, which is another mechanism, effectively. And there are other ways to put those together and put other things in. So I feel like we'll see lots of different mechanisms coming, a sort of hybridization of those that will hopefully get us to different kinds of actual artificial intelligence that we want. And then we'll see where we as humans fit into that picture, and hopefully with the right education stay on top. So I think the mistake that often happens, and is happening at the moment, is a bit, everything is solved by LLMs, because they're fantastic. The answer is no, they're not. We should look beyond that. So I think whenever you're looking at AI, think about the mechanism versus the outcome that you're trying to achieve, and try to see whether you can piece those together or can get help in doing that.
Okay, interesting. Well, just one last, well, it's not a quick question, but it's...
Things to me usually aren't. Topics.
I'll try to be brief. So
That's okay.
one of the things that, like probably many others, I've been taking Ubers for years, and I always ask the driver, how do you like it, and and particularly if they've been a taxi driver before, they love being on Uber, primarily because of the elimination of humans in the system, the politics of influencing the people at the center. And I thought to myself, is this an example of where, if we increasingly allow AI to manage parts of our government, of some of the decision making, things like that. Is that a likely future we'll see? Maybe I'm not talking about total takeover and things like that, but something we should be embracing, or?
I just think we'll see all sorts of things. I mean, I think what usually happens with these revolutions is you start by trying to put the new mechanization into the old workflow. Mm-hmm. And there are great things that can be done with it. I mean, particularly in our public sector, there are fantastic things that could be done very quickly. I think we could get a 25% improvement in efficiency in the NHS fairly quickly if we did fairly obvious things with modern technology, which we're not doing. So there's that. But then the second step is, hang on just a moment, why did we have that workflow to start with? Mm-hmm. Maybe that was totally predicated on the technology setup we had. Yeah. Can we somehow completely switch that around, do something else, so government doesn't work the same way? And I think we'll see that. Mm. I can't tell you how that'll play out, but I think that'll be a really exciting, there'll be bad things that happen, but overridingly, I think there'll be good things that happen.
Okay, great. Well, Conrad, thanks a million.
Thanks a lot, Ted.